Introduction, problem statements, equipments, block diagram, working mechanism, advantages and applications, possible advancement in this project, and conclusion. Okay. Automated standing machine is a plant driven from a basic walking stick. So, for example, if you take a basic walking stick, you have a lot of types in there. Foldable or something that is more convenient, you can multiply, fold it and keep it inside. But we don't have something to do with attachment in this. So, usually worker stand materials can be wood and royal materials also. But there is nothing called automated in this. So that's why we use which primarily uses a passive software. ASIC, which is integrated with active components such as motors, batteries, or LEDs. With wheels, this transformation moves beyond physical support, aiming to actively assign people and help them to move freely. Okay, problem statements. As we said, problem statements comes when a person, an individual, cannot access a normal basic stand because no matter if there is a stand, he still needs to use his manual power to move according to the way he wants to go. So, what if happens if a person is having a fatigue? Fatigue is nothing but if he is not well, if he is fainted, and people who are amputated. Amputated is nothing but people who don't have a minor injuries in their leg and traumatized injuries. So that is what the main cause for this invention and challenges with manual worker. Not effective for people who tire easily and have limited arm strength. As you can see, we are moving the manual worker stick, we have to move manually. So that's why we use this. Hard to use on bumpy roads and gentle slopes. So because of if the manual walker does not have wheels, so when we are moving on the bumpy roads or any staircase, it's hard for them to do more energy. Risk of falling due to fatigue and overweight balance. They do not assign movement, only support. They do not give any movement here, they only give support. Equipment. So what are the basic equipments we use here? So as you can see here, we use LEDs, buzzer as models, and then this is as headlights. And then we use motor controlling switches here. And then we will have a water stand, and inside that we are also having DC motors and batteries to power up the entire circuit. And we've also given a safety belt, Velcro belt, to ensure that the person doesn't fall. Okay, this is a block diagram. So as I've said here, what I've connected internally and what we have given externally. So this is what we have connected internally. We connected DC motor, battery, and chain packet. Chain packet is nothing but, if you people have seen cycles, the wheel. Okay, so instead of using any other extra components, we've used chain packet just so the motor can move it accordingly. And we've even created shaft so that the packet can sit inside and move along with the chain. External, same. These are the external objects which we have connected as motor switches, horn, headlight, and then our physical stand. So now I will request Preeti to take over.
So good afternoon to everyone. So I'll start my presentation with working mechanisms. So this is the right one and the left connection. So the right connection of the model and the left connection of the model. So first on, then push button, then battery, motor, then push button. So all positive is connected to push button, and then battery other end is connected to battery's positive, and motor's positive is connected to another push button, and then the other end is connected to battery, and the negative is neutral to LED. The same thing is repeated over here. Instead of on, we are using LED. So this is the output. In Proteus, first we have done the circuit diagram, we have tested, and then we have started our project. So advantages and disadvantages of this. So advantages means it reduces the effort of elderly and disabled users, then provides safe and stable movement, then it helps people at night time because of we are connected LED so that they can move freely. Then buzzer for any communication purpose, like if they are there in public places, so if they want to move, they can just press the button of on so that they can listen and they can move. Then it's simple and easy to maintain. Then applications are mobility aid in senior citizen homes. Like we can use this in home. For example, elderly people, they can use this for going to washroom and come instead of another manual support. Then same thing in hospitals and clinics. Instead of nurses, they can use this. Then post-surgery mobility support here for the persons who are fractured sure when the leg is not, one side leg is not there, that person can use this thing so that they can move for far places and come. They can use for their work purpose also. Then shopping malls and airports, elderly people, they can't walk far, so that they can use this so that they can go for their destination place. Then therapy equipment in physiotherapy clinics. Here, like this standing stick is made of aluminum, which if you give force, it can break. So rather than this, directly if you connect from base or rod, so that then we can if you make a handle so that it will be strong and they can move easily. So that's why we can use in physiotherapy and clinics this tool. Then military, in military purpose means like we can use if military man leg is short, then he can use this so that he can walk. Then after that, if that person is not feeling well, so that if other person is not feeling well, he can just make him to sit here and he can bring to his camp. So that also we can use this. So possible outcomes, other advancement in project speed control. So like in bike we can see a display, right, how much speed we are going. The same thing we can give in this also, so that the person can see how much speed he is going. And then obstacle detection. The person who can't see, we can use this obstacle detection sensor, so that the sensor can sense and tell that there is thing over there, so that I can't move forward. Then voice control, the person who is voice control, as I said, right, it can say that it can move because the object is over there. Then GPS tracking and Bluetooth or app integration, it's used for like persons like us, so that the elderly person or disabled person, wherever they go, we can track them. And if any help they require, we can help them. It will be easy for them and as well as us. Then foldable design. So foldable design means we can make it foldable also. Solar charging panel, we can make it solar charging also. Then fall detection system. If a person is going to fall, there is a sensor so that we can insert it and we can help them out from. It can sense and we can help them out. Then health monitoring sensors. Health monitoring sensors means if a person stands here, if he puts the strength on this, the sensor can sense whether they are unable, whether they are stable or not. Because sometimes the persons will not be stable. Because they can balance it or not, it can sense it, then it can move further. Like that, we can make it. Then this is the project visual representation. So first we have connected our front wheel and we have checked whether it can move to directions or not. Then second back wheel. Then we have connected. Then we have kept the components and we have checked
405.
the placements of each and every component. Then at fourth we have connected the chain sprocket. Chain sprocket. Then we have kept the motor and we have checked the distance between the chain sprocket and the motor, so that it can rotate the wheels. Then we kept a base upon this, so that if we keep the base upon this, we'll stand upon this so that it can hold the weight of the person. Then for here one motor we have done, here two motors also we have done. Then this is wire connections we have done. This is the front view of the model. This is the back view of the model. Then conclusion means this successfully addresses the mobility challenges faced by the elders and the physical challenge. By combining basic electrical and mechanical components, we have made it a successful project. Thank you.
Show the demo.
Sir, would you like to try it?
Sir, they are going.
You can try it and test it. Yeah, we have tried it.
Okay, first we'll just show you all how it works.
Take Pavitra.
So,
Pavitra, ask her.
so orange, like, so you can push buttons.
Then motor A, motor B. Motor A, it can go little slow. If you press motor B also, both also it can increase the speed. For that we have given motor A and motor B. This first motor A,
Press it, press it, press it.
it will go automatically. If you want to stop it, you have to click
You
it.
can press it once again.